A high pressure cylinder can contain a pressure of up to 300 bar. This means that the gas cylinder contains 300 times more gas than it would do at atmospheric pressure. If a cylinder valve is damaged in any way, it may become too weak and unable to withstand this extreme pressure. And this can result in a high volume of gas exiting the cylinder with great speed, as it attempts to reach equilibrium with the surrounding atmosphere. For this reason, the cylinder, and especially the cylinder valve, should always be handled with extreme care. It's recommended to perform a leak test on all joints prior to equipment use, and we will be looking at the correct procedure for this later on in the program. Most cylinders are very unstable due to their height to diameter ratio. Therefore, care should always be taken when in an area containing gas cylinders, as they can easily fall. Cylinders vary in both size and weight and can be over 1.5 meters high and over 100 kilograms in weight, making some cylinders very hard to manage. Before handling a cylinder, you should ensure you're wearing the correct protective clothing and check that the cylinder valve is shut. You must wear eye protection, strongly recommended by BOC when handling cylinders. Safety spectacles with side protection shields give protection if a valve is accidentally opened when moving a cylinder. The blast of gas, possibly containing dust or grit, could easily damage unprotected eyes. The next is hand protection, needed to protect the hands from cuts caused by burrs on the metal and from crushing injuries if trapped beneath a cylinder and other objects. Protective footwear. Boots or shoes with toe protection are essential in case cylinders fall over. They should have a good sole too. You don't want to fall over either. Wherever possible, you should use the correct cylinder trolley to move cylinders. The use of a cylinder trolley will maximize safety. However, care should still be taken regarding the surface on which the trolley is used. The experienced handler, when moving a cylinder over a small distance, can churn the cylinder. You should think about the surface on which you're moving the cylinder carefully. If it's slippery or uneven, the cylinder may behave unpredictably, causing it to move off balance. To churn a cylinder means balancing the cylinder on the rim of its base, slightly off the vertical, steadying it with one hand and propelling it so that it rolls along the rim with the other. The steadying hand can be placed on the shoulder, neck or valve top and can be the right or left hand. Churning cylinders on their bases is permissible for short distances, but wherever possible you should use a cylinder trolley. Churning is a skilled technique and should only be undertaken by trained operators. A cylinder should always be placed vertically on level ground. Standing cylinders should always be secured to prevent them falling over if accidentally knocked. Freestanding cylinders are a hazard to users and passers-by. When standing a cylinder, be aware of the hazards of uneven, sloping, slippery and vibrating surfaces, as well as loose debris. It may look steady, but as you turn away, it can fall without warning, possibly onto you. Care should be taken when attempting to lift a cylinder to an upright position, as an awkward lift could easily result in a strained back or a slipped disc. Always wear eye protection and gloves. You should consider, if it's safe to approach, whether the area around is free from trip hazards. You don't want to fall with the cylinder on top of you. Crouch by the top of the cylinder, taking a firm hold about the neck or collar of the cylinder with both hands. Keeping your back straight, lift decisively, moving into the cylinder as it rises. When vertical, steady the cylinder before attempting to move it away. This activity should only be undertaken by individuals who have appropriate physical capability and who've been trained in manual handling techniques. Before a cylinder is moved into the place of work, you should also check the cylinder valve. The cylinder must be securely fastened in either a cylinder rack or purposely designed cylinder trolley. Look inside the valve and check for any foreign material, such as particles of dirt or water. Any material detected must be removed. This can be carried out by wiping the inside of the valve with a clean, oil and grease-free, dry, lint-free cotton cloth. In case of particle contamination of the valve, it may be necessary to momentarily vent the cylinder to blow away the debris. This process is often referred to as snifting the cylinder and should always be done outside. If this isn't possible, it should be done in a well-ventilated area. If eye protection is not already being worn, either safety glasses or goggles should be put on now. You should also wear leather gloves to protect against possible ignitions of flammable gases. To carry out this process safely, you should ensure that no part of your body is in the way of the jet of high-pressure gas that will come out of the cylinder valve. Similarly, there should be no objects in the path of the gas jet, as these could provide a source of ignition or catch fire themselves in the event of an ignition. Open the cylinder valve no more than a quarter of a turn, using the appropriate cylinder key or hand wheel, and then close immediately. This process should only be undertaken as part of a standard operating procedure by trained operators. The snifting process can be used for cylinders of oxygen, argon, carbon dioxide, nitrogen, helium and air. Fuel gases such as acetylene, propane, propylene and flammable mixtures require particular caution. The properties of the gas must be considered when carrying out the procedure. Snifting must not be used on any hydrogen cylinder because the gas will auto-ignite due to its very low ignition energy. Snifting must not be used on any toxic gas cylinder. If you're unsure of this procedure, do not attempt this. Now we'll take you through the procedures to follow to use oxygen and acetylene safely when cutting and welding. We'll be using the oxyacetylene welding system as the example in this program, and we'll show you assembly, how to set up all equipment correctly and safely, how to perform a leak test to ensure connections will not leak gas, the correct procedure for lighting the system, how to turn the system off for short periods, and how to close down the system when the operator has to move away from the workstation. Before working with fuel gas equipment, ensure you're wearing suitable clothing. The correct eye protection should be worn. Overalls must be flame retardant, free from oil and grease, and well-fitting, yet easy to remove. Remember that even so-called flame-resistant textile materials will burn in an oxygen-enriched atmosphere. Gloves and safety shoes should also be worn. We'll now consider each piece of equipment. All equipment should be appropriate for the type of gas and the pressure and flow rate for the application. Oxygen equipment is degreased during manufacture to ensure safety. Oxygen equipment should never be used for any other product. PTFE tape must never be used on any cylinder valves or regulators. Ensure when fitting any equipment you use the correct spanner and never use excess force. Equipment pieces to be used with fuel gases have a left-hand thread, and those pieces used with oxygen have right-hand threads. This is to ensure that no equipment can be interchanged and to ensure your safety. Check the regulators, the threads, seats and gauges. These should all be in good condition. You should also check that the pressure adjusting screw moves freely. If there is an inlet filter, you should also check it's in place. Fit the regulators to the respective cylinders. Position the regulator so that it does not obstruct the opening and closing of the cylinder valve. If a problem arises, it's important to be able to shut off the gas flow quickly. Tighten down the regulator to produce a gas-tight seal. Repeat this procedure for the acetylene regulator. Flashback arresters are essential safety devices, as they prevent flashbacks travelling into the regulator or cylinder. Check the flashback arresters. The threads and seats should all be in good condition. You should also look for signs of flashback. This can be identified by carbon in the outlet. Fit the flashback arrestor. Ensure that the flashback arrestor is pointing away from the cylinder and that there's room to connect the hose to it. Repeat this procedure for the acetylene flashback arrestor. Hoses should be of equal length and no longer than necessary. Carefully check hoses for visual signs of deterioration and perform a bend test down the full length of each hose. BOC hoses are fitted with hose check valves to prevent backfeeding of gases. Fit the end without the check valve onto the flashback arrestor. And repeat for the other hose. The selection of a torch is a function of the application and the delivery of fuel gas. Check the torch. The torch should be free from grease or oil, and the threads must be in good condition. There must be no carbon deposits, which may suggest internal damage caused by a previous flashback. If found, the torch should be replaced. Fit the torch. Fit the mixer to the torch. And then the nozzle to the mixer. Adjust the orientation of the nozzle for comfortable use by slackening off the mixer connection, rotating it to the required position, and then lock it in place. As a matter of routine, all newly assembled equipment should be tested for leaks. Check that the torch valves are closed. Check that the pressure adjusting screw on the oxygen regulator is fully out or backed off. Always open the valves slowly so that the sudden inrush of gas doesn't damage the regulator. Using the correct cylinder key, open the cylinder valve fully and then turn back a quarter of a turn. Put a small amount of pressure on the regulator. Turn the cylinder off. Repeat the procedure with the other cylinder. Check the pressure remains constant on both regulators and no decrease is observed. A fall in pressure indicates that a leak is present. Apply leak test solution to all joints. You should use an approved leak detector spray or 1% T-Pol solution in demineralized water. Frothing around a joint indicates a leak. Should this occur, depressurize the system by opening the appropriate torch valve. Tighten the affected joint, repressurize the system, and check the affected joint again. After testing, wipe each joint with a clean cloth. Once you've ensured the equipment is assembled properly, you can set the pressures. Consult the nozzle manufacturer's guide for the correct value, and if a range is given, use the highest value. Check the torch valves are closed. Fully back off the regulator pressure adjusting screw. Slowly open the oxygen cylinder valve fully, and then turn back a quarter of a turn. Open the torch valve and set the correct pressure for the nozzle being used. Close the torch valve. Now set the acetylene pressure. Open the acetylene cylinder valve fully and then turn back a quarter of a turn. Open the acetylene valve on the torch. Adjust the regulator to the required working pressure and close the torch valve. Let's now consider the lighting up procedure. Until now, safety glasses have provided adequate eye protection, but at this point it's necessary to put on goggles with suitable lenses to protect your eyes against the intense light produced by the flame and the possible impact of flying particles. These should fit the face well and should be shaped to protect the eyes from the side as well as the front.